So, all right, Venn diagrams. We are getting near the end of probability here. So we are going to take a look. If I pictorially can see how many people or how many events occur in different places, or sometimes multiple things can occur, I can start to figure out the probability of a certain thing occurring. Now with a Venn diagram, the first thing we need to have a grip on is how many events are there to begin with. So for instance, here in example 1, each of the stars represents an event occurring. So how many events total do I have in this particular Venn diagram? 18. Okay. So my total events, or I'll just say my total asterisks here, is 18. That's important because when you're doing probability, the total number of occurrences always goes in the denominator. So we know our denominator is going to be 18 on all of these. So otherwise, just like anything else, we're just going to count them up. Now the one thing I have to keep track of here, okay, when it says the probability of A, yes, that even includes the ones that are mixed in with B in the middle here. So how many total? Okay, I got 9 A events out of 18. So I got about a 50-50 shot if I were to pick one at random that I'd get one that was out of A. What about B? 7. Okay, and that one doesn't reduce. So we'll just leave it that way.
3.
Probability, right, of A and B just means wherever they overlap, because both things are occurring. Not only are they in circle A, but they're also in circle B. So 3 out of 18, otherwise known as a sixth. Now it becomes a little more interesting. Probability of A or, and yes, we still deal with this like we did before, even though it's a Venn diagram, A or B. How do I figure that out?
Subtraction.
Okay, what am I going to be subtracting?
Well, you're going to add... Well, A, you're going to subtract the ones that are connected with A and B.
Okay, I could do...
I forgot the points, though.
Can you just add A, B to the other ones and subtract the
Exactly, okay? So I'm going to take the probability of A, add the probability of getting B, and then subtract A and B. Now, again, this is going to be showing you mathematically. There's going to be a faster way that I'll get into in a minute. Now, this is just me. I would keep them in 18ths, at least until the end, because you've got a common denominator to work with, instead of doing 1/2 plus 7/18 minus 1/6 and having to go back and do all this other work. So 9/18 plus 7/18 minus the ones in common, because I don't want to count them twice. 3/18, 16 minus 3 would be 13 over 18. If you were to just count the stars that are in the two circles, how many are there? 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Because if I'm saying that it's going to be A or B, any of these events would be a success for me on that. So when you have a Venn diagram, you actually can just count up if it's going to be A or B. Just count all of them that are there. But again, it's good to know how to do it mathematically too, just in case you get into a huge diagram sometime. You don't want to have to count everything. The probability, you're like, ooh, what's this little symbol working here? Basically, when you see that symbol, it means what's next to it. It means it's not A. So to find that, you always can do 1 minus the probability of that event occurring. So in this case, to find out the probability of it not being A, it's just 1 minus the probability of it being A. So it'd still be a half. Half it'll be A, half it won't be. Half it won't be. Okay. And then the same thing with B. It would just be 1 minus 7/18. Well, if I lose 7/18, it means I still have 11 of them. And I can get that situated. But most of the time, if you're working on a problem, it won't say the probability of not B. It'll write it this way instead. So it's just something you want to get used to a little bit. Okay. Now, that's assuming that you're getting all the information. There'll be some as we go further where they'll give you some numbers and you're going to have to fill in the different spots, but we'll get there. So if we move down a little, let's get some numbers involved this time. All right, now this is me. This is just how I work. I like when I'm getting all these different circles going. Sometimes to me, now some of you may look at this in a minute and go, yeah, you just made that trickier by putting all these colors in everywhere. But
I'm just kidding.
what's that? Yeah, and you could do that too. You could literally label in there what each thing is if you wanted to do that. I just like doing this because I see the colors on the edges of the shapes in the middle, and it helps me remember which things I'm combining for those. So let's check this out. A group of 60 students were asked if they played field hockey, basketball, or soccer. The diagram below shows, bless you,
Thank you.
shows the results. Okay. What percent of the group play field hockey and basketball? So here's field hockey, here's basketball.
2.
Eh,
Oh, 18, 20, 27 out of 60.
eh, and 5. Okay, in this group right here, notice half of my football shape here is my dark green and half of it's purple, which says everything that's trapped in this area is going to be my and. They do both.
30 out of 60 half.
So, no.
5 out of
And, not or.
I can't see.
And. So 5 out of 60, which would be 1 over 12. Yeah, and if any of you want to play with colors, I've got markers and colored pencils up front too if,
Your colored pencils are sharpened like really bad.
well, alrighty.
People waste it.
So then, let's see what else we got here. Field hockey or basketball. Now what was being mentioned before is what we're looking at, because now it's all the field hockey and all of the basketball. So basically, anything that you see. Okay. So now, here's a couple of ways I might consider looking at this. Normally when I do a Venn diagram, and I know I have 3 pieces like this, one of the things I like to do is to see how many total there are in each one and just kind of make a notation of it. So for instance, I know with field hockey, okay, there's my field hockey circle. How many people play field hockey, even if it's combined with another sport? Okay, so I've got 18 and 4 is 22, 25. Okay, it looks like I've got 27 total that play field hockey. Because again, anything in that dark green circle, whether they're playing 1 sport, 2 sports, or 3 sports, as long as one of them's field hockey, I just want to keep that in mind. So if I move over to soccer, 10, 5, 3, and 4, I believe is 22. So I've got 22 people that play soccer. Might be with some other things too. And then finally my basketball, we've got 17.
It's only 49.
Okay.
I don't know.
So here's how I kind of take that on. I say, okay, so when I get to field hockey or basketball, I know 27 out of the 60 play field hockey. I know 17 out of the 60 play basketball. And how many do both?
7. Field hockey or what? Soccer? Or basketball?
Field hockey and basketball. How many do both? We just figured that out. 5. So I can do it in pieces. Bless you. Oh. But just like before, again, if I just looked at the numbers inside my field hockey and my basketball circles, 18, 22, 24, 27, 32, 39. So you can just count them up if you wanted to do that for the or part. How many played field hockey and soccer?
7.
7. Because there's my overlap with my 2 green circles. So 7 out of 60. None of the
11
3
out of 60.
sports. Now 11 out of 60. Okay. Now how did you come up with 11 out of 60?
I add up all the numbers inside. I knew all the Venn diagrams. You only get 29. There's 60 people that get it.
Okay.
Students.
Because some of you may say, well, wait a minute, well, if I count these up, that's more than 60. Well, that's true. But then again, you'd have to look at how many get subtracted with multiple sports that they're playing here, where your overlap is. So for instance, let's see here. I'm trying to think, using Ben's explanation, how I can explain this again. Ben, go one more time with yours, and be loud so it hears on here.
I just added all of the numbers in each of the circles, like all of the numbers in there, and I got 29. And I'm subtracting this.
Okay. So if I add all of these up, 18 and 4 is 22, 32, 35, 40, 49, just by adding up, sort of like what we did up in the top with the stars. So I had 49 in the circles. And I know there's 60 total. And that's where my 11 of none come from, okay? So sometimes we even got to come up with numbers that aren't even in there. Amazing. And then how many only played one sport? Look for the parts in the circles where there's no overlap. Okay? Because that's going to be this 18, because they're just playing field hockey. They're not combining with any others. We've got 10 that just play soccer. And we've got 7 that just play basketball. So 18 and 10 and 7 is 35 out of 60. And again, we always are going to reduce with that.
Does it 39 over 60 reduce?
Ooh, by 3 it does. Nicely done. I got going a little too quick.
So then I did have it right.
Okay. Any issues so far? It's just one of those things, again, of kind of being able to decipher what you're looking for. We got a couple more to play with anyway. All right, to the back. Uh-oh. Out of 40 students, 14 are taking English Comp, 29 are taking chemistry. If 5 students are in both classes, how many students are in neither class? How many are in either class? What's the probability that a randomly chosen student from this group is only taking chemistry? Oh, let's draw some circles. Okay. All right, so we'll get some circles going here. Now, this is, again, just me. I like to know which is which, so I'm going to have my E and my CH here, so I know the one's chemistry and the other one's English. Okay, so how do we tackle this? Do I just write, and if you're writing with pen, don't do it. Would that be a sensible way to do this?
9.
No. Why not? Because I have some in the middle. How many are in the middle here? Okay, so 5 are in the middle. But I know that there's 14 total taking English Comp, so what should this number be? Okay? The 2 need to add up to the total number of students. So if 9 are just taking English Comp, and there's 5 that are taking both, 9 and 5 get me 14 total people that are taking English. So then I do the same thing over here. If 29 total people are taking chemistry,
24.
this has got to be 24, because 24 plus 5 is 29. We're playing with a little bit of algebra here. So once I get that situated, I can start answering the questions. For instance, How many students are in neither class? Because, right, I look here and I'm like, well, 9 and 5 and 24 mean I have 38 students here, but I know there's 40. So there's 2 that are just, taking nature class and just skipping everything. Okay, so I got 2 that are taking neither. Now, what does that mean exactly? How many are in either class? What's another way I could say that?
Oh. Ones.
When it says either, because it doesn't say both, either means English or chemistry. So how many are in English or chemistry? Just add them up.
All big numbers. 38.
I'm hearing 33 and I'm hearing 38.
33.
39, 8, 38.
38 is all of them.
Flashback. So let's flash back to here for a second, and then I think we're going to be pretty sure. Let's use these as our example. We had the and, then we had the or. So with the or, we took the totals of each and then subtracted what they had in common. So let's come back over here.
14 plus 29 minus 5.
So here, if we took the total of each, what would that be?
40.
How many total people are taking chemistry?
29.
Okay. I've got 29 total that are taking chemistry. How many total do I have taking English?
14.
14. How many are doing both?
5.
43 minus 5 is 38. Now, again, remember from what we did before, I can also figure that out by just counting up what I see here. Because these 5 students, that's not being taken into account with these 2 numbers. So that's one thing we've got to be careful of when we're doing this, to make sure that we are... What's that? Okay, yeah, so I should just say 38. I agree. I went into probability mode right off the bat. They're like, come on now. So, let's see here. Oh, see, I started looking at the next one. What's the probability that a randomly chosen student from this group is taking only chemistry?
Oh, Lord. 24 over 40. 38.
How many people are only taking chemistry?
4.
What was that? 3/5. So there is a little bit of thought, but at least you've got a picture to work with on these. Kind of goes with when we were drawing pictures before on some of the stuff. Kind of interesting. Okay, this is the challenge problem on 4. A lot of the ones that we do are not going to be as difficult as this is, but I always like throwing one of these in to see how we can fight through these.
Did you write this yourself?
This one, no. This isn't a Abruzzo special. So, suppose I discovered that my cat had a taste for those adorable little geckos that live in the bushes and vines in my yard back when I lived in Arizona. In 1 month, suppose he deposited the following on my carpet: 6 gray geckos, 12 geckos that had dropped their tails in an effort to escape capture, and 15 geckos that he'd chewed on a little. Only one of the geckos was gray, chewed on, and tailless. 2 were gray and tailless, but not chewed on. 2 were gray and chewed on, but not tailless. If there were a total of 24 geckos left on my carpet that month, and all the geckos were at least one of gray, tailless, and chewed on, how many were tailless and how many were chewed on but not gray? Wow. Okay. So, This time, we have 3 groups we're playing with. We've got the ones that are gray, we've got the ones that are tailless, and we have the ones that were chewed on. So let's see what parts we can get filled in and then how we can figure out the rest. So let's see here. What do we know? So 6 gray, 12, and 15 geckos that he chewed on a little. All right. So, So we know there's going to be 6 total in this circle. 12 total in our drop their tails. And 15 that we chewed on a little. Okay, so we know that much.
Ew.
So now, let's see. Only one of the geckos was gray, chewed on, and tailless. So there's my one spot that covers all 3, because it's got a little piece of all 3 circles in it. 2 were gray and tailless, but not chewed on. Let's see, and 2 were gray and chewed on, but not tailless. If there were a total of 24 geckos left on my carpet that month, and all were at least 1, okay. Time to do a little problem solving. Is there any of the blank spots that I can fairly easily figure out at this point?
Gray was only 1 left.
Okay, I know there's 6 total gray, and I've already accounted for 5 of them right here. Okay, so there's 1 gray, 1 left. So we know that. Now it gets a little more interesting. I know there's 24 total that were left, and we've accounted for these 6. Is there any other info that I can get from here to start figuring out the rest?
Well, for the chewed on, there's only 2 left. And then there's at least 1 for each.
Okay, now the chewed on, there's only 1 left.
There's only 2 left. But there has to be at least 1 for each.
Correct.
That means one of them has that chewed on ones has to be 1. Just
Yep.
only chewed.
At least.
Yeah.
But we just don't know how many. Because, right, all 3 of these have to have at least 1.
Mm-hmm.
So here's my first question, then we'll start thinking about this. Between these 2 places, how many more are there going to be?
9.
Okay, so between these 2, there's got to be 9. Because I've already got 3 here, and I know there's 12 total. Okay, how many have to be left between these 2? Okay, 12.
Mm-hmm.
Because there's 15 total that he chewed on a little. So you're like, okay, so what do you think might be a good idea, or at least a concept on how we might be able to start getting some numbers working here? Because I'm going to tell you, there's not a direct way to get there.
24 minus 6 divided by those numbers. Magic done.
Magic. Probably not magic. All right, let's look at this.
I'm a decent guesser. Is that okay?
Let's say, for sake of argument, some of you that are in guess and check mode, which might not be a bad idea here. Let's say you decide, you're like, okay, I want to see what happens if I say there's 2 that go in here. What's that? Okay, why would there need to be at least 3? Okay, so one of the things that you might start to notice is that you've got to have 12 here and 9 here where there's a difference of 3. So a good strategy might be to see, okay, so let's say I put 3 in there. How many would that leave up here? How many do I already have in my... Okay, I already have 6, and I need a total of 12, so there'd be 6 more there. Okay, let's see if this works. How many are we going to have left down here? 9. All right, let's see if our numbers work. Because how many are there going to be total? So 1, 3, 9, 10, 12, 15, 24. Nicely done. Okay, that's good problem solving. Because again, just understanding here that with there being 9 left and 12 left, that there's a difference of 3, this number would have to at least be that. If I'd have done something smaller, we'd have had an issue. But if you can't figure that out, just playing guess and check for a little while is not a bad idea. So that's how this is going to work. But like I said, nothing this bad coming at you on what you've got left. Or at least there's more information on things. Might be a couple like 3, but that'd be about it.
What about on the due exam?
Nothing this bad.
Okay.
So your task is to knock out the Venn Diagrams worksheet. As I'd mentioned, tomorrow we're going to be talking a little bit about theoretical versus experimental probability, and then getting started on the reviews that we'll go over on Monday, and then the test will be on Tuesday.